Transformers. What are transformers? I'm sure you've probably asked yourself this many, many times before. Well, you're in luck, because here is a transformer. So what a transformer is it is a device for transferring electricity from one place to another, but using a magnetic field. The idea is that you have a piece of metal here, which is made from a magnetic material, and this is called the core. And around each side you have a coil of wire. At one side is called the primary coil. Okay, so this is the electricity coming towards the transformer, and at the other side we have a secondary coil. What we can measure at both the primary and secondary coil, we can measure the potential difference, which is Vp, the current, Ip, and the number of turns. So we could do the same at the right hand coil as well. You'll notice here that I've indicated an alternating current. Now that has to be the case. Okay? Faraday's law tells us that the EMF produced depends on the rate of change of magnetic flux. Okay? So a changing current, because of the right-hand grip rule, causes a changing magnetic field around the wire. So we get a changing magnetic field moving through the core here, and as that passes through the secondary coil, because of Faraday's law, we get a changing EMF induced at the second coil. So these things are linked together. Now, we can write down a few equations. We know, and it comes back to this equation, because the EMFs are proportional to the number of turns, we can say that the potential difference at the primary coil divided by the potential difference at the secondary coil is equal to the number of turns at the primary divided by the number of turns at secondary. This is sometimes called the turns ratio. Okay, so if this was 4, okay, so that would mean there were 4 times as many turns on the primary as the secondary, then the voltage at the primary would be 4 times at the secondary. In other words, the voltage would be decreased by a factor of 4. The other thing we can link together are the voltages and the current. We know that power is equal to V times I. Now, if this transformer is 100% efficient, then what we should have is that the current at, the power at the primary coil, so Vp times Ip, must be equal to the power at the secondary coil. But that's only if it's 100% efficient. If not, then we should multiply by the efficiency. Okay, so the efficiency here multiplied by the power will tell us how much we get out of the secondary coil. Now, transformers are quite efficient things. Most transformers are above 90%. Nothing can be perfectly efficient. Okay, so there are some sources of energy loss here. First of all, because a magnetic field passes through the core, you can get what are called hysteresis losses, as this core is magnetized and demagnetized a number of times every second. In any of these electrical wires, you can always get resistive losses. Okay, so I squared R. If you ever go near an electricity substation, you can usually hear a buzzing. And what that buzzing is, it's the transformer vibrating at a particular frequency. Okay, because these are magnetic, they will attract and repel other metal materials that are around them that will cause them to vibrate backwards and forwards. So because they're vibrating and making a sound, then those are sources of energy loss: sound energy, kinetic energy. And also, inside this core itself, because of the magnetic field, you will get eddy currents set up. Okay, so you will get loops of current flowing around this metal core. In the next video, I'll talk about how to reduce those losses.